the airflow inside the tunnel, to maintain the airflow and to give a satisfactory and good environment inside the tunnel. Satisfactory or good environment inside the tunnel. So, basically we are relying on the atmospheric conditions here. This natural ventilation, now it occurs automatically. It occurs automatically. How? It occurs automatically due to the difference in the temperatures inside and outside the tunnels. It occurs automatically due to the difference in the temperature inside and outside the tunnel. Now, this is interesting. Nature is doing its work automatically and we are not going to make any efforts here. So, this natural ventilation, it is done automatically just due to the difference inside and outside the tunnels. But there is one thing, it is not possible to have a very effective or good ventilation by this natural system. It is not possible to have a very good, yes, it is dependent on nature. So, sometimes the conditions are not favorable, the temperature difference is not favorable. So, in 24 hours we can say not always, it is not possible to have good or consistent ventilation by this method. We have to go for some artificial arrangements sometimes. It is not possible to have good or consistent ventilation by this method. So, what to do? Then question arises, so what to do? If it is not possible to have a good or consistent ventilation, so what is the purpose? It can be improved. Now, it can be improved. This natural ventilation should be supported by some systems. It can be improved to provide what I called just now shafts. It can be improved to provide shafts and at suitable intervals. This is important, to provide shafts at suitable intervals during the construction. Now, regarding shaft, I would like to draw a small line diagram. Suppose this is a tunnel, this is the direction of a tunnel, this is a tunnel. Now, I should say these are the shafts, these vertical members. Now, if I shade these parts, it is better, it will be more clear. Now, these are the shafts. This is shaft 1 and 2, first shaft, second shaft, and so on. You can provide number of shafts depending upon the length of the tunnel. So, how will you describe these shafts? These shafts are basically the vertical wells. These are the vertical wells or the vertical passages. These are the vertical passages which are constructing along the alignment of the tunnel, and through these shafts we can have a very good natural ventilation. These shafts are supporting this ventilation systems. Now, Regarding this shaft, I would like to show you a diagram. Now just have a look of this diagram. This is a diagram of a vertical shaft. You can see, now this is a shaft at the roofing of the tunnel. This is indicating the tunnel part, and this is the shaft. As you can see, light is coming from here, of course the fresh air also, and this is the floor of the tunnel. There is a railway line here, some persons are working here, and there are a number of shafts throughout this length. So you can see how these shafts are giving proper light, ventilation and fresh air inside this whole tunnel. So this particular diagram must be clearing you that how shafts are giving you a support to this natural ventilation. The air, fresh air is coming out from this shaft. So this is something regarding the shaft system. And one thing more, these shafts are not only giving you the natural ventilation, but also there are some more benefits of these shafts to just transfer the central line through the plumb bob. For transferring the central line also, it is very important, very effective. For transferring central line, it helps. For entrance of materials during construction, entrance of men, material, once again this shaft is very helpful. So there are a number of additional advantages of this shaft. There are some additional advantages of this shaft, and regarding the suitability of this method, the natural ventilation, this natural ventilation is very much suitable. First case, if the length of the tunnel is less, if the length is less and dia is more and diameter is more, then it is suitable. Not in the case of large lengths, if the length is less. And secondly, if the tunnel is laid in the direction of wind, it is very effective. When the tunnel is laid in the direction of wind. Now these are the two cases where natural ventilation is best. It is very suitable. Now I will come to the second type, the mechanical ventilation. The mechanical ventilation, where the natural ventilation fails, the mechanical method supports. The mechanical method of ventilation. Now this method is suitable. Mechanical method is suitable first if the tunnel is long, if the tunnel is sufficiently long, we have large lengths, you can observe all over the world, we have the tunnels worth kilometers. So in those cases, natural ventilation is not at all possible. So we have to go for the mechanical ventilations if it is worth kilometers, very long. If it has a high traffic intensities, if we have high traffic intensities, once again natural ventilation doesn't solve the purpose. We have to go for the mechanical ventilation, mechanical method. Thirdly, if we experience adverse temperatures, if we experience adverse temperatures, atmospheric conditions like very cool, very much frosty area or very humid areas, in those conditions, if we experience the adverse atmospheric conditions, once again we go for the mechanical method. We go for the mechanical method, and in the mechanical method, what we are doing? We are providing mechanical fans. We are providing mechanical fans, centrifugal fans. We are providing centrifugal fans. There are one more type of fans, vane axial fans. We have lot of options. Whatever be the condition, we apply that particular fan in those areas. And we have basically three options here. The first option is, in the mechanical method, we have three options. We mechanically provide fans by three methods. The first method is by blowing air. By blowing air. By blowing air means, in this particular method, fresh air is, suppose this is a tunnel. So, with the help of blowers, we are blowing the, and if the length is too much, we are blowing the air by providing ducts. Ducts, you must know what exactly the ducts are. These are the artificial arrangements. So, by providing fans here or by providing blowers, we also called forced draft fans. By these fans, we can give the mechanical ventilation by blowing air inside this tunnel. By blowing air inside this tunnel. This method is also called the propulsion method. The second method is by exhausting, the reverse of it, by exhausting air. Once again, the second method of mechanical ventilation, suppose this is a tunnel and it's having a lot of poisonous gas, and I can exhaust this by providing exhaust fans at inlets or outlets. So, this can be exhausted outside the tunnel, and you see some vacuum is created here in this case. Some vacuum can be seen here, observed here. Due to this, the fresh air, it is observed inside. The fresh air is observed inside. So, in this method, basically we are extracting or exhausting the poisonous gases or the bad odors outside the tunnels. This is the second way how we do the mechanical ventilation. And the third one, or the last one, it is also very effective and the most common type of method when we combine these two, the blowing and exhausting. The third option which we have, it is the combination of blowing and exhaust. It is the combination of both. Now, I would like to define this by a particular diagram. Suppose by drawing this diagram, you will get a very clear idea how exactly what we do both the processes combiningly. Suppose here we have provided a valve V2. Suppose here we have provided